In this video, we're going to show you how to download both R and RStudio onto your desktop. Before we begin, let's take a moment to answer the question, what is R? If you navigate to the website rproject.org, you'll notice that this question is answered in the very first sentence. R is a free software environment for statistical, computing, and graphics. R, along with Python, is one of the pillars of modern data science. It is powerful, free to use, and will be the software of choice in this class. It has a bit of a learning curve, but once you get used to it, you'll be able to make beautiful plots and visualizations to back up your statistical analyses, and you'll have a valuable tool for validating your hand calculations. We're going to be running R through an integrated development environment, or IDE for short, called RStudio. You can find RStudio by either Googling RStudio or navigating to the website rstudio.com. Once you arrive, please hover over the Products button and click on RStudio. Taking you to the RStudio page, you'll notice that there's actually two versions of R, a desktop version and a server version. This video will only cover the desktop version. The server version only runs on Linux, and if you know what that means, then you can probably figure out how to get this version working without my lame little tutorial. Continuing, you'll notice that the website will navigate you down to the bottom where you have two options. You can either shell out $995 a year for the Desktop Pro version, or you can download the Studio open source version for free. The open source version will be more than enough for what we're going to be doing in this class. When you click on this button, you'll be navigated to a new site where RStudio will once again try and sell you one of the more advanced versions. Resist the temptation and click on download the free version. If you're watching this video, I'll assume you have not installed R before. So before downloading RStudio for Windows, you'll have to click on this button to install R. This will take you to a website where you have three options to download R for Linux, for Mac, or for Windows. I'll be downloading R for Windows since that's the machine I am running, but if you have a different type of operating system, then you'll need to click on, of course, the appropriate tab for your need. When you click on Download for Windows, you'll notice a lot of different options. Don't get overwhelmed by them. Just click on Install R for the first time. After clicking on Download R 4.02 for Windows, you should see an executable file start downloading in the lower left-hand corner of your screen. Once this finishes, open it up and follow all of the instructions on the prompts. You can ignore most of them, just stick with the defaults if this is your first time installing R. After you've completed the installation of R, return to the RStudio page and click on Download RStudio for Windows. Once again, an executable file will start downloading. When it finishes, follow the set of instructions to install RStudio as well. After installation is complete, you should see two R icons appear on your desktop. If not, click on the Start menu in the lower left-hand corner of the screen and scroll down until you see the RStudio menu and click on the icon there instead. After double-clicking on the RStudio icon, you should see a new window pop up, and your screen will be split into three sections: the console, the environment and history window, and another window which has various tabs including files, plots, packages, and help. We'll be focusing on the two right windows in our next video when we talk about importing data and creating plots in RStudio. The rest of this video will focus on the console. Double-click on the console until you see a flashing cursor appear next to the blue arrow. The console can focus as a calculator for performing basic arithmetic operations, or even more complicated arithmetic operations. But more importantly, it can serve as an environment for processing and summarizing lists of data. As a simple example, let's suppose you've conducted a survey of student GPAs, and after interviewing 4 students, you get the following list of GPAs: 3.5, 3.7, 3.6, and 3.0. You'd like to calculate the mean of these 4 GPAs and are too lazy to do so by hand. In order to leverage the power of R in this calculation, we first need to know the syntax for entering this as a list. In R, lists of objects need to be separated by commas. They need to be enclosed in both left and right parentheses. And they need to start with the C for concatenate command to concatenate all of these objects into a single list. In order to store this list as a variable to work with in future operations, first hit the up arrow on your keyboard to return to your previous command. Then we're going to assign that list to the variable x. Now notice if I want to refer to that list of objects again in the future, I can simply type x, or printx, depending on your preference. You can choose whatever you want for the variable names. For example, I could have assigned the variable name GPA to my list, as long as you avoid certain or obey certain rules, such as not starting a variable name with a number and not including certain special characters like dashes, although underscores and periods work just fine. Another way to assign variable names to lists, if you don't like the arrow notation, is to start off with the variable name and just put equal sign. Regardless of how you want to define your variable, once you have it stored, you can perform operations on it, such as calculating the mean, calculating the median, or calculating a whole range of different summary statistics, many of which we'll talk about in the next video. Of course, we'll mostly be dealing with data sets involving multiple variables and many more than 4 observations like the example here. In such cases, the import option is critical. We'll be covering that and more in our next video, summarizing numeric variables in R.